this look like, you're going to be able to tell what form this is. We just said that this was factored form because it looks exactly like we just talked what we did at the beginning of the year. This is factored form. This was factored form, and it's actually going to be two different forms, and this was factored form. Yes? Okay, remember at the beginning of the year, before we factored something, I gave it to you and it looked like this. Yes? Do you see anything that looks like that up there? Any letters? F looks like that? Yep. B looks like that, and H looks like that. That's called standard form. That's what standard form will look like every time. And notice, just like we did the other time, there's an A, there's a B, and there's a C. And we need to know where those come from, or we need to know how to identify them, because they're going to find some special things for us later on. That'll be clear in just a little bit. But like B, what is my A value? 1/3. Notice he did not say what? He didn't say 1/3 x squared. X squared is not part of my A. It's just the coefficient of the x squared is the A. So it's just 1/3. What's the B? Pi. It's okay that it's an ugly number like that. Your parents still love you. We still love pi. Okay? What about C? 6.4. How about F? What is A? 1. What is B? 12. And what is C? Be careful now. It's -1. It is -1. All right. What about H? What about H? What is A? -5. Good. What is B? -1. And what is C? And like I said, when we get to standard form, we start to use it. You're going to need to know how to find A, B, and C because we actually use them for solving this, for being able to graph this. And then last, we have this right here, which is called vertex form. What do you think vertex form gives you? Gives you the what? Say it louder. It gives you a vertex. I mean, hello. Sometimes I never understood why kids said math was so hard. Science, I can kind of understand it because those scientific words are really crazy. Like dog is really like some stupid long Latin word, right? Like, and I get why they do that. The Latin words have root words and all that, but I don't speak Latin, so that's hard for me. Vertex form. It gives you a vertex. Factored form. It's factored. I'm talking to you like this is it. Yes. Which one? Yes, D is also vertex form. And we'll talk about why D is also vertex form and when we get to actually finding out what each one looks like and what they give you. Does that make sense so far? Now, please understand this. Any parabola can be written in any three forms. In fact, do you remember? Let's look at H right here. What could you, since the beginning of school, I told you how to do what to that? How to factor it. So you could take this right here, standard form, and you could turn it into factored form. Now, this is not the factored form of that. But you could do the math, and you could factor this, and then you would take a parabola that was in standard form, and you would have changed it into factored form. Kind of like in linear, you had things that could be in standard form. Again, there was a linear had a standard form. There was slope-intercept form. You remember those? And there was point slope. And a line could be written in any three of those forms, and it would still be the same line. Are you with me? If I change this to factored form, all I've done is change the way it what? Looks. I have not changed its what? Values. In fact, if I was going to factor that, just to give you a hint, just to show you that this is what you would do, I would actually factor out a negative first, and then make it 5x plus x minus 21, and then I do my factor gain. You can factor out a negative, That way I hold on to this negative out here. Does everybody see why I would do that? And then I would do the 5 times the 21 thing that we did before. This is not a perfect square, it's not difference of squares. It's a doesn't equal 1, and I'd solve it that way. Did I tell you factoring was going to come up real quick? All right. Are we clear on kind of what everything looks like so far? All right. We should be on page 95. This right here is going to be a very important section. This is what every one of these guys, standard form is going to be, this is the generic form. A, B, and C will be numbers. So when I give you a specific example, they'll actually be filled in. But depending on which number I give you, the A, the B, and the C can change, right? It's not, A is not always going to be 1. Notice what happens after the comma. What does it say? Y? So what does that mean? A can be anything in the world except for, why can't it be 0?
If it were 0, then it makes the x squared 0 as well, and then you would have an x squared.
And so what kind of equation would you have?
You would just have
There would be no x squared.
Yeah.
X would, the highest power x would be is to the first power, which is what type of equation? Come on, we did that all last week. Linear. Remember we talked about, as soon as I see x to the first power, I know it's going to be a line.
Then it wouldn't be quadratic.
And this would not be quadratic anymore. So I wouldn't be in standard form of a quadratic because it wouldn't be a quadratic. So that's why a has to be some type of number. It can't be 0. Are you with me? Okay. Why can't this a be 0? Because if I take 0 times a number, what do I get? And 0 times another number would be, so if I had 0 times a number, it would be 0 times another number was 0. That means that f of x would equal 0. Is that going to make a quadratic? That's just going to be a straight line that says no matter what x I put in, I'm always going to get what out? 0. That would be a straight line. It would actually be a vertical line straight up. No, straight across. It'd be a horizontal line, sorry. It'd be a horizontal line. It would be the x-axis. Because what is my y every time I'm on the x-axis? 0, right? And that's what this would be doing. Right here, if this was 0, 0 times all this would turn into what? 0, and then 0 plus k would be? So this would equal k, which would just, again, be a straight line. This would be a straight line. This would be a straight line if you did these things over here, which would make it not a parabola or quadratic anymore. Are you with me on why they had those stipulations? All right. Here are going to be some key characteristics for when we graph parabolas. We're going to look at their x-intercepts. What did I just say? Whenever you are on the x-axis, what do you know? You always know that the y is 0. If you think about that, every time I'm on this line, I'm changing the way I go left or right, but I'm not changing what? My up or down. So x, comma, y is always an ordered pair, right? Basically, I think of this as a giant treasure map, and the first number tells you how far to go left or right. If it's positive, I go right. If it's negative, I go left. And the second number tells me how far to go up or down. I think of Jack Sparrow and his stupid counting that he did within marketing, and all he's trying to do is find the rum, and then they burn the rum, and he gets like, but why the rum? Right? And he freaks out. I don't know what I'm talking about. You don't know? I guess you're too young for Pirates of the Caribbean?
Oh, can't you just like jump in the ocean or something?
No, she burns it. To make a big fire, so because the ship, she's like, everyone's out to sea, he's ticked. He's like, but why the rum?
You gotta get rum like really hot to burn, right?
No, he wants
Alcohol.
He wants to drink
with
it.
alcohol. It's not like Everclear where it's like 100%.
Oh my gosh, we're not all, sitting here seeing how much we can burn alcohol.
It's like vodka works burns really good.
It sounds like you've done a little too much burning of alcohol. We're gonna move on. Sounding a little bit. Hope your dad doesn't listen. He's burning all your alcohol. All right. So, I think of the Jack Sparrow. Yes, recording, so this will be fun. I think of Jack Sparrow, but that's exactly what this is. This is a giant treasure map, and you're saying this right here says right and left. This says how far to go up and down until you get where you need to be. So when I tell you guys to go 1, 2, you know to go right 1 and up 1, 2. So you know to be right here. That's how this whole ordered, graph thing works, right? But when I'm on this, what have I changed each time? Each time I've changed how far I've gone left or right. What hasn't changed no matter what when I'm on the x-axis? My y is always 0. That is going to be the x-intercepts. So, how's that going to help us? Well, exactly. My y-intercept, x is always going to be equal 0. But let's take that, because this is what kids don't do a lot, and we're going to do this a lot in this class, so we need to understand it. Y equals, and I'm going to go linear for just a minute, because we're comfortable with linear. And it's going to apply still to quadratics. If I said find the x-intercept, what would you do? Before you can do any math, there's fire. What did you just say? You just sit there and told me, if you have the x-intercept, what do you know? So what can you do right here? You can take out that and put a 0 equals x plus 2. You can use algebra, minus 2, and you can say x equals negative 2. So you can tell me the x-intercept is negative 2, comma 0. Or whatever I just did. Are you with me? Whenever someone gives you an x value or a y value, how can you find the other one? By plugging whatever that is, because it's not always going to be 0. Like, if I say x is 1, how can you find the y value for that? Plug in 1, and 1 plus 2 is 3. Hopefully not 2. It's okay. Brain farts. They stink. We'll be all right. Right? 1 plus 2 is, there we go. And then we know that my ordered pair would be 1, comma, 3. Whenever you want to know the other value, you just plug it in. So what if I said I want the y-intercept? What would you do to this equation over here? It would say y equals what? 0 plus 2. Because all you have to do is do what? Plug in the value. And you know if you're on the y-intercept, x is 0. If you know you're on the x-intercept, you know y is 0. Are you guys following me? We plug in a lot of values. We good? Thumbs up, down, sideways? Question? Which part? All right, you get it, some? Okay. All right, Vertex. This is only to find the x-intercept. So if I said find the x-intercept, you would plug in y as 0, and that would get you your x-intercept. If you wanted your y-intercept, you would plug in 0 for x, and that would get you your y-intercept. All the other points aren't key. We are talking about key characteristics because sometimes you're going to have intercepts, sometimes we won't. We'll talk about that too. But these are just the key components. If I wanted to find where x was 1, that would just be some random point. And I could plug it in. But we're going to try to graph these fast and use the smartest points every time. Intercepts are going to be smart points. Now, like I said, sometimes they won't intercept, but we'll talk about that scenario and when it happens and what it's going to look like. With me? Okay. Vertex. The vertex is going to be the most important point on a parabola because it's kind of like, I think of it as the starting point because it's what kind of separates the right side from the left side? Do you notice the right side looks what compared to the left side? Yeah, like it's mirror image. And actually, there's this thing called, like you guys just said, there's this thing called the axis of symmetry, which is the next word under there. And notice, where did the axis of symmetry go through? It goes through the vertex every time. So here's a basic way that we're going to graph parabolas. I'm going to ask you to graph them, just like you know how you learned how to graph linear and all that. We're going to learn how to graph parabolas eventually. Very soon. Well, the first point you're going to get is the vertex. You should star that. You should highlight it. I don't care what you do. The vertex is going to be a key point. You have to have the vertex for that parabola. Are you with me? Then what you do is you can find 2 points on the right side. Technically, you could find 2 points on the left side. I don't care. But either on the right or the left, you need to find 2 points. If I know this point was over 2 and up 1, what do you know I'm going to do on this side? Over 2 this way and still only up 1. And I'm mirroring it. Over 4 up 6. Let's pretend that. What am I going to do? Over 4 up 6, and boom, I'm going to mirror it. So technically, how many points do I need you to have in order to graph a parabola? I need 5. How many do you actually have to work for, though? 3. You got to work for the vertex, and you got to work for these 2. But then the other 2, you can just what? Mirror it. Are you with me? Now, the axis of symmetry. Let's say my axis, or my vertex is 5, 7. Again, I told you I like to go back to Algebra 1 and whenever I can to make sure we understand concepts. We didn't miss stuff. So, here's what happens. Can someone tell me the equation to that line? It's an Algebra 1 concept. X equals 3 is the equation of that line. Because no matter what happens, what is my X value? How far have I gone over? I've gone over to the right 3. How far have I gone over to get to this point? Still 3. What did I change from this point to this point? Which is how high I went up. By the way, does how high I go up change how far, or how far I go over? Does it change how high I go up? This is going to be a constant. Y or X is always going to be 3. Whenever you have a vertical line, it's always an X equals equation. What would be the equation of this line? And that one is Y equals 2. Look at our axis of symmetry. What type of graph is it? It's a line. And it's a vertical one, so it's going to be an X equals. But he just told me X equals 0. It's alright. It's a good try. I like that you got the X equals part. But let's draw this on the graph. So let's say I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. It starts over here and goes up, and you said, this is my axis of symmetry. X equals 0, Mr. Martin. That's where it's mirrored at. Is that the axis of symmetry? Where's the axis of symmetry? Right here. Okay. Right there. What's the equation of that line? That would be, and notice, watch how easy this is. If someone asks you which on the test, I will say graph this. Find the vertex. Find the axis of symmetry. Once you have the vertex, all you have to do is go X equals 5. So if I said a vertex is negative 10, 2, what's the axis of symmetry equation going to be? No. X equals -10. Don't forget that x equals. That's it. That's going to be, I promise, 100%, a question on the test. I'm going to ask you to graph, and I'm going to ask you to label all those things, and you'll get points by just writing that. Is that really that hard? Hopefully not. Yes. What? Not in this type of, for this parabola. Later on, we're going to talk about these guys, and then their axis m is going to be like that, which would be a y equals m. But we're not going to be there in this chapter. I don't believe we go to these guys. But I'm very careful with saying always, never, that kind of thing. Most of the time there is a scenario where that can happen. Do we understand vertex? Vertex can happen either here, or it can happen here. We understand the axis symmetry, where that falls. We just talked about it. You might want to take some notes on just writing how you find the axis symmetry, or at least understanding what it is. Concave up means the graph goes up. Concave down means the graph goes down. On your test, again, I will say, what is the concavity of your graph? And all you have to put is, if it looks like this, up. If it looks like this, you will put in that little space, down. And I will have kids who put IDK. And it's really sad. Are you with me on this? Are you with me? Concave up, concave down. It's going up, it's down, down. Make it tricky again. All right, a couple more things. It wouldn't talk. We're not. Don't worry about those graphs. We are only worried about parabolas, which are going to be x squared and that kind of thing for right now. All right. Let's talk about something that you should know a little bit about: domain and range. If I say domain, it should not be scary. If I ask you for domain, what am I asking you? What is x allowed to be? So if I look at this graph right here, does this ever stop going to the left? Will it eventually get way over here? Sure, it might be like 200 feet in the air. And you might have to graph that thing forever to get to it, but this never stops going to the left. Does it ever stop going to the right? No. So what I want you to look is, this is a little symbol that we do that means all reals. And again, we've talked about this. Yes, there are numbers that are imaginary, and we're going to talk about them this year, but we haven't got there yet. But this symbol just means all reals. It says it can be any real number. So, if we wanted to talk about the range, what does range have to do with?
Y.
What can y be, right? So if I look at this, how far up does this thing go? Does it ever stop going up? No. Does it ever stop going down? Yeah, right here. That's the lowest point. So we actually call this kind of graph, it has a minimum. Because they're going to also on the test, it's going to say, does this have a max or does it have a min? And your minimum will be y. What's the range going to be? Y has to be what? Let's look. I'll make this number up. 5, 7 again. We'll use that. That's my ordered pair. What do you know about y? It has to be 7 or what? Or greater. It can't be lower than 7, because if I have 6, I'm down here, and that doesn't exist on my graph. So y has to be greater than or equal to 7. That has to do with that idea of domain and range, max and mins. This right here would be if we had 5, 7, again, we'll use the same one. My domain is still going to be all reals. My range now is going to be y is what? Less than or equal to 7. Because it has a maximum. This has a max that it can be. What's the max? 7. It doesn't go any higher than 7. What do we think? Monday? Alright, now the last part. We're actually going to get to this a lot more tomorrow, so this is where we're going to pick up. This is our last part. I wanted to start this a little bit. Standard form. Standard form looks like this, where I have an A, a B, and a C. I am on page, which you need to get to, 97. Now, in standard form, what did I tell you was the most important thing? Remember I said vertex is going to be the most. I said star that sucker, we're going to need it, right? So I'm always going to talk about the vertex first. When I talk about how to find the vertex of this, to find the x-coordinate of any of these guys, if it is in standard form, I take the opposite of b and divide it by 2a. Some of you are going to go, what the heck are you talking about, opposite of b over 2a? If I give it to you in standard form, opposite of b refers to that number right there. Over 2a refers to 2 times that number there. Does everybody understand that? If you simplify that, meaning you divide it all out, that will give you the x-coordinate. That means of your vertex, you need an x and a y. This formula right here will give you the x part. Are you with me? If I do opposite of b divided by 2a, if they gave it to me in standard form, that will give me the x part of my vertex. But the problem is, I don't need just an x, I need an x and a. How did I tell you just a minute ago? I said you need to use this, we're going to use it all the time. If I say this is your x, how can you find your y? What can you do? Yeah, but that was a specific example. What did I tell you to do if you want to find? Plug it in. So you would plug x in and solve for y. So that means you're going to take this guy right here that you found. You found this x-coordinate by doing this equation. You would then take it and plug it into up here and solve for what y would be. And that would get you your vertex. We'll do actual examples tomorrow, but that's kind of an understanding of it.